Alright, welcome to the Notes on Domain and Range, which is the 6th lesson so far in this unit. So, I'm going to start with some vocabulary. The first word is domain. And what domain is all of the existing x values. It's all existing x values. Therefore, range is all existing y values. Okay. And finally, an interval in math is a way we say from here to here. So for example, an interval of time is to say, like, I slept last night from midnight to 5. I'm not saying just at midnight and just at 5 I was asleep. I mean every single second between midnight and 5 I was asleep. Right? So it's like everything from 12 to 5 and in between. So an interval is a way to say from A to B and everything in between. All right. So, let's say we're trying to do domain and range with a table. With a table, it's really easy because remember, domain is all the x values. So you always want to list your domain and range from smallest to biggest. My smallest x I see is 2. The next one's 3. The next one's 7, but I don't have to list it twice, even though it shows up twice. And then the last one is 9. So that's all of the x values that exist. For my range, all of the y values that exist, my smallest one's 0. My next one's a 3, then 5, then 33, then 86. So when it's a table, domain and range is really easy because you just list them as you see them. When it's on a graph, it gets a little more complicated, mostly because there's lots of confusion about graphing and what graphing means. And so I'm going to go back and talk about some misconceptions real fast to help clarify some of this stuff. For example, I don't know if you've heard of this word. It's called coordinate plane. And a coordinate plane is an x-axis and y-axis with no graph on it. Meaning, if I have this, an x and a y, with some tick marks labeling my scale, it is not a graph yet. This is not a graph. It's a coordinate plane. It's the blank thing we put graphs onto. Kind of like when you're painting, a canvas is like the painting with nothing on it. And then once you start adding paint to it, it becomes a painting. So once I start putting points on it, it becomes a graph. But without any points on it, it's just a coordinate plane. That's the name of it. This is a coordinate plane, this is a coordinate plane, because there's no graphs on it yet. So for example, when I look at this coordinate plane, right, I'm going to put a point on it at 1, 1. When I look at that, and I ask myself how many points are on this graph, there's only one. The one little point. And it makes it a graph. It's a graph now because there's a point on it. So then let's say I put 2 isolated points. So one at 1, 1, and let's say there's one at 4, 4. It doesn't really matter where you put those points. The point is right now, there's 2 of them. There's one right there and one right there. Go ahead and turn your page. The camera died, so I'm going to re-explain everything you see written on the paper. First of all, I put a dot right here at 1, 1, and another dot right there at 4, 4. Then I connected the 2 dots with a line. So there was a big dot right here, and a big dot right here, and I connected them with a line. And the question are, how many points are in this graph? And the answer is that there's an infinite amount. Now, sometimes people see like the 2 big points, and they're like, oh, there's only 2. But that's not true. The whole line is millions and millions and millions of points. Because technically, a line is millions of points really, really, really close together. Because right after this dot, there's a dot right there, and right there, and right there, and right there, and then there's millions of them all the way to the next dot. And because there's so many of them and they're so close together, it just looks like a line. However, it's not just 2 points, it's millions of them all over that line. And remember that every single point has an x and a y. So if I'm trying to ask what the domain of this graph is, and I just copied the exact same graph right here, a point at 1, 1, a point at 4, 4, and I connected them with a line. And so if I were to want to know all of the x values on this graph, it would be really, really difficult for you to list them all. It would take your whole life because there's millions upon billions upon trillions. There's an infinite amount. So I'm not going to ask you to write them all out. Instead, we're going to write intervals. For example, the domain on this one was this point, the smallest x. Remember, x's go left or right. And so if I'm saying small, I'm starting to look on the left side, right? There's nothing at -8, nothing at -7 or 6 or 5, nothing at 0. But right here at 1, this is the first point I see starting on the left. So it's from 1 to, how far do the x's go? Well, there's a bunch of x's between 1 and 2, because there's a bunch of points, because that's the line there. And through 3, and until 4. My last point ends at the x being 4. So, what is my domain? It's everything from 1 to 4. Well, what about the range? Well, range, remember we start with the smallest one, and the y's go up and down, and the small direction's down then. So if I start at the bottom and start working up, there's no graph here at -8, no graph at -6, no graph at 0. The first point I see on the y's is right here at 1. And it keeps going up all the way up till right here, which has a y of 4. So the range of the graph is also everything from 1 to 4. Okay? Well, this graph was blocked in both directions. There's a hard dot here and a hard dot here, but there are no arrows. So let's say I have a point here at 1, 2, then it has an arrow going like that. So that points at 1, 2, and then there's an arrow going up and to the right. So if I have to list the domain of this graph, remember the smallest x I see, so starting on the left, the smallest one I see starts right here at 1. So it's everything from 1 to, how far does this graph keep going? Well, there's an arrow, and it's going to continue. So it's going to keep going right. There's going to be an x at 8 around here. There'll be an x at 10 around here. There'll be points at all those x's forever and ever. So we say everything from 1 to infinity, because that graph is just going to keep going forever and ever. And then, so what's the range of this graph? Well, remember, range means the y's, and the small y's are at the bottom. There's nothing down here, no graph down here, until right there at 2. This point starts at 2. So the range is everything from 2 to infinity. Because it starts at 2, and then it just keeps going up, because these arrows, this arrow means it's going to keep going up forever. So like the y of 6 has a point right here, the y of 8 will have a point about right there, and it's just going to keep going. The y of 10 will have a point, all of them will have points. So let's go ahead and do one more on the next page. Okay, so this graph, I'm going to have a point right here at 1, -2, and then it's going to curve up that way and curve up that way. So for the domain of this graph, remember, domain is the x's, and the smallest x's are on the left side. So like, is -8 going to have a value? It is, because this arrow is going up to the left, so it's going to be all the way like up here, but it will eventually hit the graph. What about further back? Well, there's an arrow going to the left. This arrow is going to keep going up and towards the left forever and ever. So technically, how far backwards on the x's does it go? It goes all the way back to negative infinity. So it's everything from negative infinity to, how far right is it going to go? Because 0 has a point, 1 has a point, 2 has a point, 3 has a point, 4 has a point, 5, 6 has a point, 7, 8, 9, 10. It's going to keep going forever and ever to the right because of that arrow. So it's going to also go for forever, all the way to positive infinity. Okay, remember range is how far down the graph goes, because it's the smallest y, and y is down. And if you can see, this point was down here at negative 3. There's nothing beneath it. The very bottom one was negative 3. So it's everything from negative 3 to, how far up? Well, both these arrows are going up, so it's going to keep going up forever, all the way to infinity. So here's the thing. We don't like writing words in math because it's a lot to say everything from blank to blank. So instead, we write intervals. And intervals is a special way to say everything from blank to blank. And here's how they work. For domain, you take the smallest value of x that the graph has. And the smallest value of x is going to be less than any of the x's on your graph, right? Which is also going to be less than your biggest value, because all the x's on your graph is going to be less than your biggest value of x. So these little inequality signs, they're called inequalities, and they're like little alligators, and they always eat the bigger number. So this is saying the x's that exist, they're bigger than whatever the smallest one is. And then they're also less than whatever the biggest one is. So it's basically saying everything from here to here. For range, it's the exact same. So you do the smallest value, which is less than any of your y's, so because it's range, use the y's, which is going to be less than the biggest one. Okay? Remember, I'm going to remind us of a couple things here. Domain was x's, and x's are left and right. So the smallest value for x is on the left side. Like, how far left does it go? And the biggest value for x is on the right side. So you ask yourself, how far to the right does it go? Okay? And then for range, the smallest value, range is y's, which is up and down. So the smallest value is how far down does it go. And the biggest value is how far up does it go. There's something else to say real fast. This symbol right here means less than, right? And less than means you're not including it. So if I'm saying less than 3, I'm not including 3, right? But a lot of these include 3. Like, a lot of them have points at 3. So this sign means you're not including that number. Versus if you want to include it and say it's a part of the domain on range, use this, which means less than or equal to. So this includes the number. Basically, if it's a number, you're including it, because there's usually going to be a dot at that number you're talking about, right? However, you can't include infinities. Infinities should get this symbol, okay? And because the reason why you can't include infinity is that it's not a real number. Infinity just means like forever and ever and ever and ever, so you can't include a number that doesn't actually exist. It's a pretend number. So for example, if I wanted to say everything from 2 to 4, and let's pretend this is the domain. The domain, whatever we're talking about, is everything from 2 to 4. You would write it like this. 2 is less than or equal to x, which is less than or equal to 4. because the smaller number goes there, the bigger number goes there. The middle part doesn't change, so you use this for domain. The only reason why I put equals on it is because there's numbers, and I want to include 2, and I want to include 4. Okay? So how do I know when to use infinity and negative infinity in my domain and range? It's basically about the arrows. So for domain, if I have an arrow going to the left, you use negative infinity. So this arrow, for example, right here, it's going towards the left. So I would use negative infinity. And then if there's an arrow going right, that's the positive direction, so I use positive infinity. And the reason why the arrows tell me is because it means it's going on forever and ever, it's continuing to go. For the range, if I have an arrow going down, it's negative infinity. And if I have an arrow going up, it's positive infinity. Okay? So we're going to go back through each one and write the things we said in words in inequality notation instead. So here, for the range, let's do the domain first. If I want to say everything from negative infinity to positive infinity, I put the 2 parts on each side. X goes in the middle because it's domain. And then they don't get the equal sign because you can't include infinity. For the range, if I want to say everything from negative 3 to infinity, I put my smaller number on the left and my bigger number on the right. Y goes in the middle. I put my 2 lesson symbols, and then the 3 is the one that gets the equal sign because the 3 is the number. And you can't include infinities, so that one doesn't get the equal sign. So flip back to the previous page real fast. We're going to do these ones too. If I want to say everything from 1 to 4, I do that because it's domain, it gets an X. They get their 2 inequality symbols, and they're both equals because they're both numbers that had hard dots at them. For range, everything from 1 to 4, there's a Y in the middle. And then they both get equal signs underneath the inequalities because you're including 1 and 4. Here, if I want to say everything from 1, and include 1, it's domain, I'm putting an X. To infinity, you cannot include infinity, so you don't put an equal sign. And finally, everything from 2, you include 2, so it gets the equal sign. It's range, so it's a Y. To infinity, infinities don't get the equal signs. And that's all of the domain and ranges in interval/inequality notation. So quickly, there's one more note to make because this comes up in the worksheet. Division and dividing by 0. So if you don't remember, something like 8 divided by 2 means that I have 8 things going into 2 buckets. So each bucket gets 4. Okay? Because the number on top is how many things you have, and the number on bottom is how many buckets you're dividing them into. So if I have like 8 pennies, putting them in 2 buckets, each bucket would end up with 4 of those pennies. So let's say I have like 0 divided by 2. That means I have 0 pennies, 0 things, going into 2 buckets. So each bucket gets none. So the answer to 0 divided by 2 is 0. Because if you have nothing that you want to put in 2 buckets, you end up with nothing in each bucket. However, let's say you wanted to do 2 divided by 0. Well, that means you have 2 things in your hands. And they're going into 0 buckets. So what's the answer If you actually typed it into the calculator, it would say error. Because it makes no sense. Makes no sense. You can't put two things into no buckets. Which means, therefore, we cannot divide by 0. You cannot put things into 0 buckets. So there's a rule, you cannot divide by 0. If you put it into the calculator, it would tell you error. Okay? And that's important because if for some reason you plug in an x and you end up at the end trying to divide by 0, that x is not a part of your domain because you can't divide by 0.